Hello everyone. I am Abhinav Sharma. I am 14x certified in Azure, including Azure DevOps expert and Azure Solution Architect expert. I'm also a Microsoft certified trainer. I am a Gold Microsoft Learn Student Ambassador and a GitHub Campus expert. Currently, I'm working as a software engineer and cloud automation engineer with various consulting firms across India. That is pretty much about me. Apart from that, I am a active community member and a community leader. I have been leading various communities as a sponsor, as a speaker, as an attendee at various parts of India, and I love to interact with the folks and love to share my knowledge and also learn from the folks all over the globe. That is pretty much about me, guys. Let's dive into the topic for which we are gathered here. The topic is Azure AKS 101. So Azure AKS stands for Azure Kubernetes Services. So this is a managed service offered by offered by Azure, which is used to manage the Kubernetes at a very ease. One who are not well much aware about the Kubernetes and its practices, Azure gives you a fully hands-on and a fully optimized way to set up the Kubernetes as your own cluster. Before diving into what Kubernetes is and what is AKS, let us first understand the need and why is this being implied into the market, right? With that, I must say, from many years ago, the companies have been shifted to the monolithic architecture. The one who don't know about monolith architecture, let me tell you. We have servers, the centralized servers over which the complete code, the user management, everything is handled over that single platform. But what is the complexity or the need which make it the birth of Kubernetes, right? So you can understand that by the invasion of more and more product-based companies, more and more products into the market, the complexity of the code increases day by day. At each day, at every day, there is new bulk of new chunk of code have been developed by thousands of developer all over the world, right? And with this, there is an increase of centralized code, and with this, there is a hard complexities between maintaining and debugging those codes when it comes to the part of any failure or the resolution of those failures. So this makes monolithic architectures fails, and here comes the role of microservice architectures. So microservice architectures will help you in embedding, it will help you in debugging those problems, those codes at a very ease. And you don't have to just skim through the complete code. You can just decentralize your complete application into sub applications, and those sub applications can be managed very easily. So with this, let us dive into our today's agenda of this session come workshop. I already told you about me, and then let's dive into the agenda, right? So our agenda will be in this order actually. First, we will look into what is containerization. Second, we will be looking into the Kubernetes overview, what is actually the Kubernetes. Then we will see the containerization application development, means how containerized applications are developed and delivered to the client or the market. And then we will see the AKS overview, like what solution the Azure brings up, what solution the AKS brings to you. And finally, we will see a small demo of how to set up a Kubernetes server, Kubernetes service over your Azure account, right? So first of all, let us understand what are containers. So containers are nothing, you can just correlate it with the sandbox. The guys who don't know sandbox is something like a small you can say an OS or small environment where you run your code, where you run your dependencies and everything. Similarly, container is a kind of sandbox. I'm not saying that it is a sandbox. Just to ease you to correlate it with, I'm just exclamating it with the sandbox. So sandbox, it will help you in packaging your applications. Wonder a situation where in a company you have developed an application that is a basic application created in any programming language. Now you have developed this application for a client. Now how do you deliver that application to the client, right, in an effective way so that he can run that application as it is on their own system, on their own environment, without configuring any extra parameters, right? in that situations, containers proven to be very successive way to deliver your applications, to deliver your packages or your codes, right? You write a code, you just put it into a container is like a box, and you just ship that box, you can just gift that box to your clients, to your stakeholders, right? Now containerization is you can say is a process. Containerization is a technology, right? It's not a tool. So what are the tools which helps you to do these containerization process, which helps you to create the containers? So the very popular one is the Docker, right? The one who don't know about Docker is one of the popular container runtime technology or a tool which we use to create the containers. Apart from that, container D, and there are various products available in the market alternative to the Docker, but Docker is mostly used because it is an open source, and there are multiple and you can say millions and billions of containers and codes are available open source. Also containers helps you to give the complete features that the Linux offers, right? Although containers are now also being available for the Windows based systems, but popularly the containerization we do generally for the Linux based environments due to the compatibility and the success of the Linux in the market. Okay, so with this, let us understand a bit about Docker, right? What is Docker and how Docker works, and what basic functionalities of Docker are there in the market. So, Docker is actually an open source platform, and it is open source because anyone can come, anyone can contribute in it, anyone can store anything in it, and it's absolutely free of cost. Although they charges, but at the enterprise level, you don't have to pay anything if you are just trying and using the Docker at the individual levels. Many developers, programmers, open source contributors use Dockers a lot to deliver their product, to deliver their code to the clients and the stakeholders again. So this is actually the platform, basically the developers and the system admins use them a lot. So if I talk about who are the people who started using Docker first, so I can say that Docker have been an emerging technology into the DevOps culture. In starting, the DevOps person should know the Docker. If you have been into any company for an interview as a DevOps engineer or a cloud engineer or a system admin, they would definitely going to ask you about what is Docker, how you use Docker, how you perform different functionalities into Docker, right? So why is this a mandatory skill? Because every Kubernetes in fact starts with a container, and to run a container you use Docker and other technologies of course, but most of the times in most of the organizations, in most of the scenarios, Docker is preferred most, right? There are many cloud based technologies also available in the market, but that are the private you can say the hubs where you can store your images. Now DevOps people use Docker to ship the products, to create the containers, but now developers must also know the Dockerization. It is considered that if you are a developer, you write the code and you also was able to ship your code, right? There is no need of system admins to do that for you, because this is your code, so you should know how to use it and how to deliver it to the clients. So basically it is used to develop, deploy and run the applications. So I guess these three functions, these three features of Dockers are very clear to you. What is development, what is deployment, and what is running the applications. So basically the principle on which the Docker is running are the building, shipping and running. So building, I mean that whenever you create any Docker image, you first need to build that, right? Whenever you, if you need to use something, first you need to build that, right? That is a common phenomenon of life also. So similarly with Docker, first you need to build that application. So for by building, I means you import all the dependencies, you import all your code, the code which you must need to deliver to the client, not the secrets, right? It is best practice to import the secrets as an external variable, but that is completely a different thing. So this is how you build an application. Then shipping comes, you need to host your application, host your Docker image. The one you create is called a Docker image. That Docker image needs to be held at some place so that your client can download it from there, right? That is a common phenomena. You cannot just share it locally. So for that reason, we have two ways. First is the private hubs, and second is the Docker hub itself. Docker hub is an open source and anyone can see your image. You can also create private repositories also, but generally we create the public repos. And there, from the public repos, anyone can go to the URL of that Docker and can install your application. And after, the last step is running that application. So there's a very simple command for that. We use Docker run command and name of the image, and it will help you running that application perfectly in your system without doing any extra configuration, just installing the Docker itself, right? This is how, like, I also use Linux into my Windows system. This is my Windows system, but I just prefer to use the Docker. I create the Docker image of any Linux OS, either CentOS, Red Hat, Ubuntu, anything, and then I just use to test and deploy various features and everything. And after that, if something fails, I just delete that Docker image and reinstall it. It just spin up a new VMs within just seconds, right? You don't need to do any manual configuration for that. Okay, now just focus into this very main part of today's this session. This agenda is Kubernetes overview, right? So Kubernetes is entirely a different technology, right? Kubernetes, I can say one can have a subject of Kubernetes development because it is entirely a different domain, different space which you need to understand. And as much as you dig into it, as much as deep it gets into, right? Because Kubernetes is basically the microservice, you can say it's a container orchestration. So what do you mean by an orchestration? So the one who know about software development lifecycle, SDLC. So orchestration stands for storing the images and managing the lifecycle. The complete management of something is basically, you can term it as an orchestration. So container orchestration means Kubernetes helps you to manage the containers which you created, the containers which you are running, right? Multiple containers can be managed using the Kubernetes very easily with few couple of commands running over the kubectl, right? This is basically the main functionality of Kubernetes. Google was the one who founded the Kubernetes. So it's again an open source system. You don't have to pay anything to use Kubernetes like tools. And it's nowadays almost every big organization, startups are using Kubernetes as their primary resource of infrastructure. Why? Because no one wants an overwhelmed response from the developer teams or the stakeholders that there's a bug and you need to fix it, but it takes a whole lot of efforts plus times and the consumptions of the resources. Kubernetes helps you to break down the complete complex architecture into the small ones, and then you can use those architectures to the different teams, different parts. For example, let's say you have a e-commerce website. On that e-commerce website, you break that e-commerce website into a Kubernetes or a microservice based architecture. So what breakdown you will do, right? For example, cart have another microservice, the products have another microservice. Similarly, different features have different microservice, and there is a team of 2 to 3 people assigned to each microservice. So can you imagine how easy it will be for everyone to manage and maintain their complete? Although there are some issues, not issues, but there are some, you can say, the drawbacks or the careful features are also of the benefits of the Kubernetes also available. But still, it's a way more better to manage the services like this instead of a centralized server or a centralized architecture. Now, what Kubernetes is focused on? It is focused on scheduling, scaling, and self-healing. So what do you mean by scheduling? Scheduling means whenever you create any pod, whenever you create any service, so you must schedule it. Schedule means you must know when and where you need to publish that service, right? So Kubernetes manages that part for you. Then scaling. Scaling are of two types: vertical and horizontal scaling. Scaling means whenever you need to scale your architecture. If demands increase, you scale up the resources like the compute, network, and storage. When demands goes down in some off season, you let's say, then you scale down. For example, the travel websites, the demand increases in the winter season generally in India, so the scaling needs to be scaled up so that traffic comes up and there is no site crash downs up. So that is again a feature of Kubernetes. It scales down and scales ups your architecture very easily without a manual overhead doing a lot of consumptions of the resources at all. Then self-healing. For example, anything goes into failure, so Kubernetes have a feature of recovery. You can recover all your pods. I will explain you what are pods, but let us understand pod is as a service, as a service entity, right? So you can manage that service properly, and Kubernetes will self heal it. Self heal means if it fails, it retries to run it again, right? And it occurs sometimes. They are the HTTP request, and HTTP based requests also fail sometimes, right? Get request, post request. So Kubernetes helps to retry those efforts on their own behalf. You don't have to do anything to make it work, right? So that is an overview, complete overview, what Kubernetes is and how you use Kubernetes, what are the features of Kubernetes. Now let me tell you the flow. By the flow I means what are the, you can say, the major components of the Kubernetes. So basically Kubernetes work on a master worker architecture. A master node is there and a worker node is there. Node means you can just understand node it as a computer, right? Two computers are there. One is the master computer and the other one is the worker computer. Right? Node have the resources such as compute, network, and storage. So that is a node. So there are two nodes. You can have more than two nodes. You can have two worker nodes. You have three worker nodes. You can have architectures like two master and three worker nodes. So, but very similar and a very basic is the one master and one worker node. So master is the one who handles all the admin related efforts. Admin related efforts means validating the APIs, scheduling the different parts to the different services to the different parts of the Kubernetes, and authorization, authentication. These things are managed by the master node. And what is the worker node? Worker node is basically the place. It is a playground where everyone can come and play. What I mean by this means worker node is just a resource. It provides you the resource to run your services. Your main application, your main microservices are not run on the master node. Master node just helps you to communicate between different microservices, different architectures. But these microservices are hosted, or you can say they are maintained over the worker node. So these have different sub parts also. Master nodes have API scheduler, etcd servers, and worker nodes have kubelet and kubelet proxy. And we will look into it better in this diagram. So this is basically the Kubernetes flow, how it works, looks like, and how it works. All right. So let me tell you this architecture, and this is common for all types of cloud-based Kubernetes services, whether it is Azure AKS, whether it is GCP's GKE, Kubernetes Engine, whether it is AWS EKS, it's Elastic Kubernetes Services, I guess, yeah. And now many cloud providers like DigitalOcean, Tencent, Linode, Hetzner, these different clouds I've worked with, they are also providing their own Kubernetes-based architecture. So you can understand the demand of it, whether these small clouds are also using it, right? So let me have a pointer to point this out. Yeah. So this is a master node. As I told you, master node is the one which handles all the requests, and it helps you to communicate between different worker nodes, right? And this is a worker node architecture. Master node does nothing but authorization, authentication, and connection between different services. There's nothing which we can do manually over master nodes, because it is something managed by the Kubernetes system itself, right? And it should be managed by Kubernetes system itself, because they are the very crucial services which, if they are maintained manually, can cause the errors, and the issues in the master node can fail your complete Kubernetes architecture, right? So these are generally the very sensitive nodes, and you should not play with these nodes. I've played, I know that can create a havoc, right? So let's not go into it, but yeah, this is a very major node. If you want to deep dive into it, just study about the API servers and the HCD. They are the one which you are managing the all the calls which are happening into the Kubernetes. The major part which we are interested in, the worker nodes. So worker nodes can be one or more than one worker nodes could be there. Within the worker nodes, you have the container runtime, which is obvious, right? Kubernetes is just container orchestration, means they are managing the containers. Now, what that containers are built upon? They are built upon Docker. Generally, I'm just exclamating it as Docker. There are different runtimes also supported by Kubernetes, but let's for ease, let's take this container runtime as a Docker, right? You are using Docker as a container runtime within the worker nodes. Like your node will have the Docker installed. Just understand like this, right? Then there's a network proxy, which we also call kubelet or kube proxy. So network proxy is basically helps the external users or the internet to connect to your worker nodes, right? Because this is a complete packed architecture, no one can go into it until and unless there is a proxy. We use ingress controllers generally. Most of the times you have heard of Nginx, right? Nginx. So this is used as the ingress controller, ingress proxy, which coordinate with these network proxies, so that the people from the outside can also access into your clusters. Not the complete cluster, but they can access the resources which you have given right to, right? Now comes the pods. So pods are basically the small virtual machines. These virtual machines are responsible for having your code and running them, right? The container images, running your container images. And finally, the add-ons we generally do it for the features, some features that we want into it, like the UI and the DNS, etc. So that is the architecture of Kubernetes. So these are some objects are very important, because in Kubernetes these are the things which we manage actually. First is the pods. As I told you, pods are the virtual machines on which your code resides. Now these pods are controlled by three types of controller: deployment, stateful sets, and jobs. So these are different controllers means how your pods will be provisioned on the Kubernetes. Either you can create a cron job for some specific period of time so that it can run. You can have the stateful sets so that your pods persist the data of the user for the next calls, right? Stateful and stateless, that is the simple meaning of that. And deployments are general that we do without the stateful sets. That's the stateless, you can say, but not every time it's stateless. Then if the services, now how your pods can be accessed. Now there are three types of services: cluster IP, load balancer, and the node balancer, node port basically we call it. So cluster IP is something that it will give some internal IP so that services can communicate within itself, within the cluster, within the Kubernetes architecture. No one can outside could access it. And load balancers and node ports basically give that a public IP so that the people from outside can also access that specific service or specific pod or a deployment, right? Now let's come into the part which we are here. Azure AKS is everything which we have studied till now about the Kubernetes. The only part which makes it different from the Kubernetes flow or the primitive Kubernetes architecture is it is a managed Kubernetes services. By managed, I means that master nodes are completely managed by the Azure. You don't have to play, or you don't have to configure the master nodes all by yourself. Azure is the one who will manage those master nodes for you. Although you can also configure those master nodes, but by default they are configured and managed by Azure itself. The customers or the we are only responsible for managing the worker nodes, creating the different services, creating the architecture, etc. So managing the master nodes is a very major task, and after that all the complexities of the setup is over. Now you don't have to do a complex setup now, and also it optimize your code, right? You don't have to know what machine instances I should use in order to provision my architecture, right? everything is managed by Kubernetes itself. For master nodes, you can still configure your worker nodes, right? And I guess you are aware of nodes now, okay? And now this is an architecture of Azure Kubernetes services. You can see here the master nodes are managed by the AKS and the worker nodes are managed by the customers itself. So API servers, etcd, scheduler, these services or these components are all managed by Azure. You don't have to be worried about it. All you have to look into are the nodes, the pods, and everything, the objects which we have discussed now, right? So that is a difference. In the Kubernetes, these both things should be managed by the user. But if we talk about Azure AKS, this is the part which is managed by Azure. That is why it is called managed Kubernetes service. And this is the part which is the user is responsible to have, right? Where we deploy our code and ship it to the customers or the stakeholders, right? So this is the complete architecture. And now let's go into the demo of setting up a sample cluster for us, right? So before that, there are three prerequisites. Either you are on a Linux system or a Windows or a Mac. These three could work either way. We don't have any complexities in these three OS or any other OS if you people are using and preferring. So these are as first, you must have an Azure account, right? To create a service, Kubernetes is a paid service, so you must have a free trial account. If you are a student, you can opt for a student account. If you are a professional, you can just go for a free trial. You can use that free trial to provision the clusters and all. Then you must have an Azure CLI installed over your terminals or your command prompts. Either way it's possible to install. And finally, you must have kubectl. So kubectl is a command line interface, command line terminal, which helps us to interact with the Kubernetes, right? I'll show you how to use the kubectl commands, kubectl CLI. So these are the three basic prerequisites. Now let's jump into the demo part, right? All right. So first, this is a website, guys, for installing the kubectl. You can go here and as per the OS, you can download the kubectl and install it on your system. It's very easy to install on Linux based system, but I'm currently using Windows, so I have installed the Windows part of kubectl. Then you guys can have the Azure CLI, right? So you can install this Azure CLI simply by going to this. You can just search for download the Azure CLI, and you can see here there are various distributions available, right? For Windows, Mac, and for Linux also they provide for OpenSUSE, Ubuntu, CentOS, Mariner, etc. Right? And you can also install it on the Docker containers as well, right? And finally, there is an Azure account. So if you want an Azure account, there is an you can activate a free account which provides you, I guess, yeah, here you can see it provides you $200 credits, and you can use this credits. What it says, yeah, that you can use the free services for 12 months, and these $200 can be consumed for the paid services for the 30 days of sign up, right? This is for the professional. For students, you can use it for the 12 months. So if you are a student, that is beneficial for you to have an Azure account. You can have GitHub student pack, developer packs, and you can just go there, use your consumer credits, right? So these are three prerequisites. All right, now let's jump directly into the Azure portal. So this is the website, portal.azure.com. So here, when you go into it, you can see the portal something like this, right? So here you need to create a Kubernetes services. So go to create the resource, and here search for Kubernetes, Azure Kubernetes service, right? And when you search the marketplace, here you can see the first service which comes up is the Azure Kubernetes service. Just click on it, and now just click on the create. This will help you to create a new provision, a new cluster for you. Now, before in Azure, whenever you create any cluster or any resource on the Azure, you first need to have a resource group. Within that resource group, you assign all your projects. So for this workshop, let us create a new resource group, right? So let us name it Azure Demo RG. So naming can be anything. You can keep any name, but in a one account there cannot be a similar two names. You have to keep a unique name. So Azure Demo RG is the new resource group that I am going to create. Now the cluster configuration. So now they are asking you what type of workloads you are going to run on it. This will charge you according to that. So for example, if you are using something like standard, so in the standard anyone can create the simple production like of workloads, right? It will provide you the least you can say downtime, or provide a good SLA, right? But currently we are doing a testing and development, so we can just go with the dev test. It will charge you least, right? And there are other conditions also. If you are using some machine learning kind of workloads which needs GPU processing and all, you can go with the batch processing for real-time data for IoT and stuff. But we can go with dev and test as of now, right? Now it is asking you for a cluster name, so I'll put a name like this, cluster, right? So this name is acceptable. You can just check it, what are the parameters of keeping a name. Then it asks you for a region, in what region you actually want your cluster to be running. So for demo purposes I'm keeping it in central US, but if you are working as a professional for any clients, just keep in mind that your region should be nearer to the clients who are using it, for the least downtime and lagging of your clusters, right? For now we can go with the central US because there is no dependency for that. And it can also offers you the availability zones, like every region have 2 to 3 availability zones for the physical data centers. So you can have any number of x number of availability zones available here. And again, it's a test, so I'm not keeping any availability zone. You can if you want. Now it is asking you for the Kubernetes version. So by default a version is selected, but if you want to upgrade or downgrade to any other version of the Kubernetes, you can go with that, right? And finally it is asking you what type of availability you want, what is the SLA you want, service level agreement, right? So for the dev and test purposes I'm good with 99.5% availability, means it will be 0.5% per year it will lag or it will not be able to access, right? If you want something to be more available, you can go with the 99.9%. Now it's asking you for the node size. So node, as I told you, there are worker nodes and master nodes. Master nodes are already configured by Azure itself. Worker node is something you need to be care of, like how much resources, how much of compute or memory power you want into your resource. So here you can see different kinds of machines are available, which we have selected is a 4-core CPUs. It has 16 GB of RAM, and I guess it's enough. And for demo purposes I still don't want this much. And also you can see as you increase the number of RAMs and the CPU, the cost is also increasing. So as depends on your workload, you can just select it. I can just go with this 2-core CPU and 8 GB RAM. That is an ideal selection for me. I don't need much into it. Now how many node I want, right? So there are two methods. Either I can auto scale, whenever loads is more, it can auto scale to 2 to 3 worker nodes. And I can also do it manual. So it will ask me how many worker nodes you want. So let us keep into auto scale. We don't want to do scaling at our own. Now it is asking you for the node pools. So node pools are basically, you can say, a place where nodes are kept, right? So currently there is a by default one node pool within which you can have 1 to 5 nodes, 1 to 5 worker nodes, right? So I'm good with that. I can go ahead. And then it is asking me for the encryption, if I want any encryption on the OS disk, the disk which is attached to the node pool, right? If I want that, I can do that. But by default it is doing the encryption with the platform managed key. You can bring your own key also. It provides that functionality also. Then if we talk about the access, so access, either the local accounts can access, or you can have more refined access into it. The one who are connected with your Azure account can only access, so you can go with either of the options for that. And the one who are registered can only access your cluster. But currently I can go with the local accounts because again there's no dependency for that as well. Now the networking part of Kubernetes, which is very important, which lets you to know how your cluster, how your nodes going to be interacted with each other, right? So there are different availabilities here. You can use kubenet or Azure CNI. You can go with kubenet. Azure container network interface are other options available for us. We can do that as well, but that there's no need to do that currently, right? You can go with the definitions also, like what these two services. I can just yeah, all right. Yeah, you can see the definitions of both plugins also. What is the use case of Azure CNI and what is the use case of kubenet, right? So you can everything they are providing you the reference to read what that stands for. For example, this is the HTTP application, so here you can see what that stands for, right? It makes it easy to access the application and etc., right? Now let's go to the integration. So integration is basically your cluster is integrated with several other services of Azure, right? For example, you want monitoring. So that monitoring can also be managed, and you can enable the monitoring into the cluster so that it provides a log to know whether your cluster is up, it is failing, why it is failing, and these kinds of stuff can be managed using Azure monitors. Then Azure container registries is used to store the images, right? The image, for that you need to create a container registries where your Docker images are held, right? So for advanced, there's a CSI drivers. CSI is container storage interface drivers, which whether you want it or not, you can have it, and you can store the secrets, the variables. As I told you, external parameters, right? You could not store it in the containers. Then tags basically helps you to manage your services all over the Azure premises, right? You can just search for the tags and can know where and in which resource group your resources are holding, right? So that is something other optional these are optional feature. If you want, you can have it. And now finally I can just go to review and create. So it is doing some validations checks to check whether I have selected the right options or not. If any option fails, it will say me ki, please go back and just fix that part to provision your cluster. So it's a quite time taking process, and it says the validation is passed, and this is the configurations which we have done, right? This is the complete configuration of a Kubernetes server. All right, so now we can create the server. Now server creations can take 5 to 15 minutes. So I have already created one server for you. So how to access your server, just go to Kubernetes services, and here you can see your clusters. So we have created a cluster already, but that is into the provisioning state, right? You can see the deployment is in progress. So just we can go and check out this already created server. All right, a cluster. So how can you connect to your cluster, right? So just click on the connect option, and it will give you some commands that you need to run your terminal, Linux terminal, Mac terminals, or the Windows command prompt, right? So what I'll do is, let me open my command prompt here. Okay, so within my command prompt, let me increase the font size, guys. Yeah. So first of all, first step after you configure your Azure account is to do AZ login. AZ login is a command which helps you to log into your account. So it will open a terminal, and here this is my account, Azure account. So once I log in, it will fetch the information of my account and will say ki, yeah, you are authorized now, and now you can use this account for accessing your resources. So with this message, with this JSON object, it says, yes, I am organized now and I can access, authorized now and I can access now, right? So next will be the commands that we need to run. So this is the first command. Just you can use your own command set of commands, right? Which you can see from the connect button here, right? Just paste this, and yes, it has set the subscription into this newly created Azure CLI account, right? And finally it will fetch the credentials of the cluster which we have just created. So it says that the cluster configurations are set and merged into this path. In my system, it will go into this path. when I go into that part, I can see the configuration of the cluster. And now how I can know my cluster is configured. So so you can have a command. Let me do CLS. Yeah, you can have a command called kubectl get pods. So currently there are no resources because it's a fresh created server. I can use ns. So when I go kubectl get ns, or this command can also be used as namespace. None other same thing. So whenever I go, you can see here there are 4 by default namespaces are created. So this signifies that I have successfully installed the server and have done the complete configuration of the Kubernetes cluster, and this cluster can be accessed from my local system. You can see this is my local terminal, and I can access this cluster perfectly within my local CLI local command prompt, right? So these are some command sets. You can just go and search for kubectl commands and run various commands. There are command says kubectl get pods. This command is basically gives you the all the pods or all the containers which are running into this cluster currently. Currently we have no pods running into it because this is a fresh server, so no resources found into the namespace, right? This is the default namespace. You can create your own namespace by this command kubectl create ns, and just name any namespace, and you can have your own namespace created here. So this is how you set up a Kubernetes cluster, and yeah, as you can see, this cluster is taking a process, but this is none other same thing. This is how you set up a cluster into the Kubernetes. And thank you everyone, and this is all from my end. Yeah.